Alright, so as I mentioned in the last example, when we were multiplying a binomial times a trinomial, that's going to be the most complicated type of multiplication that we're going to see. We had a bunch of terms when we were going through and doing our multiplication. In these last few examples, we're going to focus on multiplying binomials. So when we're multiplying two binomials, since we do have binomials, we're still going to use our distributive property twice. Right, so we're going to distribute each term of the first binomial to the second binomial. As we're going through and we're doing these, sometimes we hear the shortcut FOIL for first, outside, inside, last. So we'll kind of talk about what that means. Again, we can think about it as FOIL. FOIL is really just using our distributive property twice. And then we go into the last couple of examples. We're going to generalize some of our results as formulas for squaring a binomial or a difference of squares. But to start with, we're just going to focus on multiplying two binomials. Again, as we're going through this, as we've done in every single problem in this section, we are multiplying our coefficients and adding our variable exponents. All right, so let's start with example A. So we're taking x plus 2 times x plus 5. So we're going to start by distributing our x. Now, we can go through and we can rewrite our problem. Or we can show our distributive property just by simply using arrows. Right? So if I think about that, I'm going to distribute this first x to that x, and I'm going to distribute that first x to that 5. Right? So as I do that multiplication, x times x gives me x squared. X times 5 gives me 5x. Now I'm going to distribute my 2 to everything in that second binomial. Right, so 2 times x is 2x. 2 times 5 is 10. Now if we look at this, we do have two like terms in the middle here that we're going to combine. Right, so we're going to combine those two terms to give us a final answer of x squared plus 7x plus 10. Now where the shortcut of the word FOIL comes from, that's mentioned up here, this first, outside, inside, last. To get this x squared, we multiplied the first term of each binomial. To get our 5x, well, we multiplied our outside terms. To get our 2x, we multiplied our inside terms. And to get that 10, we multiplied the last term of each binomial. Right? So if you see or hear the word FOIL, if that helps you remember what to do, feel free to use it. If you want to draw in the arrows, feel free to do so. I will continue doing so as we go through a lot of these problems. Again, if you want to leave them off, that's fine too. Just remember that as we're going through to get our final answer, we want to make sure that if we do have any like terms, those terms are combined. All right, so let's work through B. Right. So again, we're going to start by distributing this x. So x times x is x squared. X times negative 7 is negative 7x. Now we're going to distribute our negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 7 is going to give us a positive 21. Again, we can combine our middle two terms, which are like terms. We get x squared minus 10x, remember same signs we add, plus 21. Right, so let's work through C. Again, we're going to start by distributing our x. X times x is x squared. X times negative 9 is negative 9x. Now we're going to distribute our 4. 4 times x is 4x. 4 times negative 9 is negative 36. Right. Again, we're going to combine our middle two terms. X squared, a negative 9x and positive 4x, different signs, so we subtract. So we get negative 5x minus 36. All right, and one last one down here at the bottom. We're going to distribute our 3x. Three x times 2x gives us 6x squared. 3x times negative 1 gives us a negative 3x. 4 times 2x gives us a positive 8x. 4 times negative 1 gives us a negative 4. Again, we're going to combine our middle two terms. We get 6x squared. Different signs, so we subtract. Larger number is positive. Plus 5x minus 4. Now looking at these examples, notice that all of these started with just an x term for our first term. That's going to be true in a lot of homework problems that you're going to see. We could throw different variables in there. That's also a possibility. We could have higher powers on our terms that are inside, so that's also a possibility. In all of these, we were able to combine those middle two terms. Again, that happens a lot of time, but not necessarily every time. There is one more thing that I do want to point out, though, before we go on to our next example. Notice that in example A and B, both of our binomials had the same sign in the middle. Both of these had plus signs, both of those had minus signs. Right? So sometimes we refer to these as binomials with the same sign. Notice that in both of these, our last term happens to be positive. So I'm just going to make a little note here that if we have same signed binomials, we get a positive last term. Now, this semester, we're not really going to use that fact that much. However, next semester, if you take Math 95, we do a lot of factoring. And we're actually going to be starting with this trinomial and working backwards to figure out where it came from. And as we're doing that, our signs are going to be key. So just kind of thinking about this, making you aware of this now, hopefully that helps you out a little bit next semester. Right? Then notice that for C and D, right, we have one positive sign and one negative sign in each of those. So we have different signed binomials. And notice that in both of these cases, our last term is negative. So we're also going to make a little note here that says if we have different signed binomials, we end up with a negative last term. Again, for right now, just pointing out some information to you that will be hopefully more useful in the future. Again, as we're multiplying our binomials, we're distributing that first binomial to that second binomial, right? And so we're using our distributive property twice.